Hmm. Good evening, everybody. I hope my voice is audible and the video is audible as well. I mean, the video is visible as well. So, this is day 13 of us doing live every day. And actually, we did computer organization of 2025 paper yesterday. And this is our progress. Right. One. Oh, okay. I kind of did programming as well, dude. I did not write it. Wait, let me write that one as well. All right. Let me check programming. My bad. I feel like we solved all of this. Did we do this one? Yeah. 3 times. We did this one actually. Okay. Actually, you allocate memory for box N and box is a pointer. Uh-huh. Okay, box C is equals to head. So head of next is equals to box N, okay. Box N of L is equals to index, alright. So let's kind of see if we did this or not. I remember doing that one though. Yeah. No, it did not come this deep, I guess. Yep, let's do from 2024. I did that one, I'm sure of it. Programming 2025 is completed. So that's it, and we just need to do a CN. Alright. So computer networks it is. Alright. Address resolution protocol ARP. Okay, yesterday's alright, it seems. Yep, we did something. Right. Okay. And this is day 13, I see. No, it cannot. Alright. Address resolution protocol provides a mapping from IP address to the corresponding hardware link address. A single TCP segment from sender S to receiver R cannot carry both data from S to R and acknowledgement from a segment. Both it cannot carry. Okay. So this is called piggy banking. I have remembered that one. So it said it cannot carry, but that is false. It actually can carry. So 2 is false. So it only comes down to 1. It is either B or D. ARP provides a mapping from IP to the link layer. Okay, IP to MAC address when a host needs MAC address from an IP. Alright, yep, I remembered that one as true, but we just needed to confirm. Alright, so computer networks are ARP. So as you can see in the name itself, address resolution, it resolves the problem regarding the address. So IP to MAC, you can say, and piggy banking S2R data and ACK previously sent from R to S. Piggy banked. Okay, piggy backed my bad. Piggy backed ACK acknowledgement. That makes sense. And routing protocols. Yeah, we absolutely do not know this one. Distance vector routing, and I know these names, but I don't know which algorithm is used for which routing. So that is a knowledge based. Seto was so high that having such question. Still Seto was hardest among all in recent years. Yeah. Distance vector routing is Belmont-Ford technique because each router shares a distance vector with its neighbors, and Belmont-Ford uses it to create the shortest path. Yeah, like all pair shortest path we use Belmont-Ford, and for single source shortest path we use Dijkstra. I know that because every router builds a complete map of the network link state database and independently computes the shortest path test tree using Dijkstra's algorithm. Distance vector. All right, let's write some theory. So basically, right, by using this. Okay. So Bellman-Ford is R pair shortest path. So distance vector routing sends vector cost of our known destinations. I wanted to write this one even though I read that. And Dijkstra single source. So link state routing. Yeah, just to be clear, I did not read computer networks. So it is obvious that I do not have the necessary theory for that one. But still, we are supposed to do it. We ignored compiler design because compiler design is you need like more theory. But at least for computer networks, I watched a 10-hour video sort of, so it is alright. And I mentioned this is an IPv4 datagram. The protocol field of the IPv4 header has a protocol number of protocol X. The protocol field of the IPv4 header has a protocol number. So this is the only given information. So we should know the protocol or one of these options that do not contain these. Right. Multiplexing and demultiplexing. Routing information protocol. Okay, we do not have the necessary theory for that one. So, ChatGPT it is. Okay, not this one. IPv4 Internet of a Partial System. One envelope, okay, I know that. Like packet, datagram. At various layers, the names changes. Right. Inside the IPv4 header, there is a small field called protocol. Okay, after this packet reaches the destination machine, which program should it open it? Mm-hmm. So the protocols field stores the number that tells the OS ICMP, IGMP, TCP, UDP. So the protocol field of the IPv4 header has a protocol number of a protocol X. So the payload of the IP packet belongs to protocol X, okay? What kind of protocols can appear in the IPv4 protocol field? Okay, IP packet directly contains protocol and data. If a protocol is carried inside TCP or UDP, then it will not appear there. Got it. ICMP messages, IGMP, multicast group management, OSPF, so RIP, alright. So the key point is, let's write this one because why not? Right. Purpose of protocol after this packet reaches destination, which program should it open? Okay, so only protocols directly carried inside IP appear there. But RIP is part of UDP. Alright. Routing Information Protocol RIP. Consider a network that uses Ethernet IPv4. IPv4 do not use any options. Field, oh my god. The problem is you badly wanted to sneeze, but the sneeze won't come. The feeling is just different. So each Ethernet, let me just get my Okay, the highlight scene is I did not share my screen until now, and I noticed that now. Yeah, I hope now my screen is visible and the single viewer who's watching that did not say that. But that's alright. Anyways, yeah, this is our screen. And so IPv4 headers do not use any options field. Each Ethernet frame can carry a maximum 1500 bytes in the data field. A UDP segment is transmitted. The data in the UDP segment is 7488 bytes. Okay, we need that question seems really easy. To find the last segment length, instead of writing 1480 times, you can just total. Yes. I mean, that's common sense. So, MTU, what is MTU? 1500 bytes. Maximum bytes, alright. So, you are supposed to know this one 1480 bytes. I thought he said that one as well. Okay. Payload of UDP segment plus UDP header. Uh huh. Now fragmenting the payload. Alright. So that is basically how the data packets are sent inside a network. I have understood that one. Still, I just watched it for semester exam video. I did not watch the GATE series of computer network, so I don't know any of these things. I just know what the question is talking about. And this one too. Alright, a UDP segment is being sent over IPv4 inside Ethernet frames. Max Ethernet data field 1500 bytes. This must contain the entire IPv4 packet. But UDP itself has a header. All fragments except the last must carry data in multiples of 8 bits. Because fragment offset field counts 8 byte units. Really? Yep. So what did this guy do? So I guess it is wrong. 116 bytes. Mm-hmm. Okay, it is not wrong. We just did not have the necessary information. So 96 plus 20 header size 116. Okay, so let's write this one as well. right? So Ethernet, it contains the IPv4 packet, and it contains the UDP protocol, and it contains data. So IPv4 without options is 20 bytes. So we need to know them. UDP header is 8 bytes. So 28 bytes is packet size is given as 1500 bytes, and the fragmentation rule is multiples of 8 bits. I have read that one too. So 28, how much is that? 1572 bytes, but fragmented data must be multiple of 8 bytes. So 1572 more. Let's get our gate calculator. 196. So 196 times 8. 1568. Okay. So total, what's the size that needs to be transmitted? 7488 bytes of data. 748. Wait. 7488 by 1568. Um, is that correct? So we missed something up. Okay. So how did 1500 bytes become 1572 bytes? It is 1472 and my math is not mathing. So 1472, my bad. 184. So that is exactly divisible. So how much total data needs to be sent? Payload of UDP segment 74, right? 7488. Cha. So UDP payload is 7488, but UDP also has a header. I see. So the packet contains an IPv4 header, it contains a UDP header, and it contains payload. And the entire data, let me show that. So let's assume this is the entire data. This is UDP header, and it will be transmitted as a lot of packets. Each contains something like IPv4 header, and let's change the color, UDP header. So similarly, right, Can we kind of copy this one out? I don't know. All right, nice. Yeah, nice, nice, nice. Control V. How to grab this one? How to grab that one? No, what I meant is like, okay, you can, I guess, paste it over here. Yes, sir. Wait, you cannot grab it or what? Okay, whatever. You get the idea. You get the idea, yeah. So it is divided into multiple such packets. And so, yeah, that's what we are calculating. So total payload is 7488 plus 8 header, that is 7496. Yes, sir. And now that's needed to be split among 1472. 1472. 7496. At least it is not a numerical type of answer. If it were, that kind of messed everything up. So 5 full packets. So how much does 5 full packets can carry? 1472 times 5, 7360. 7360. So 7496. 7496 minus 7360. That is 136 remaining. You need that one? No, like 7360, 7496. Okay, something's wrong. Mm-hmm. That is still 136. 6 packets. Okay, wait, what was asked? What is the size of the last fragment including the IPv4 header? Mm. So 7496. Oh, wait. You need to do for 7488 or 7496. Like 7496 is including the header. So will that header be transmitted? So 1472 is data. Alright. So the above one should also be data, right? So 7488 it is. So payload is 7488. Okay, UDP header is 8 bytes. IP header is 20 bytes. IP payload is UDP payload plus UDP header 7496. Okay. MTU payload 1480. So 6 packets, alright. Last 8 fragment. First is 1480. Okay. IP header is okay, yeah. The total payload also contains a IP header, right? Absolutely. So you are missing that part. IP. Yeah, now you can do IP by IP. Plus 8 header, how much is that? 7496. And plus 20 IP header. So how much is that? 7516. Mm-hmm. Maximum fragment payload. Mm-hmm. Per IP for standards, the payload of every multiples of 8-bit fragment offset field. It's okay. 1480. So 7496 of payload, and how much can that payload take? Like the fragment 1472 plus 8. Oh my god, including UDP. So 1480 size. Oh god, including UDP. So that gives 5 and plus extra 96 bytes. So 96 bytes with UDP plus IPv4 header is 116. It is as simple as that. So combine the UPv4 header and which one? Combine the UPv4, I mean IPv4 header and UDP header. You will get that. So treat this as 2 units, right? IP and payload. So this payload may contain UDP. We don't care. That made calculations way easier. Okay, suppose we're transmitting 3000 frames. Is the screen visible? Yeah, the screen is visible. Two nodes using stop and wait protocol. The frame size is 3000 bits. 2000 bit per second and the propagation delay is 100 milliseconds. Okay, so it is basically channel utilization. Okay, frame size is let's try to do this. Frame size is 3000 bits. Transmission rate is 2000 bits per second. Delay is 100 ms. The processing times are negligible. The size of the acknowledgement packet is negligible. Channel utilization. So utilization percentage. It seems easy to be honest to me. Uh, so it need to divide into one frame. Yeah, that's what I'm thinking. Transmission time is 1.5. Okay. Propagation time is 100 milliseconds. Okay. Utilization is transmission time by. Okay. Transmission by trans plus 2 times propagation because it needs to go and come back 2 times. So 100 into 10 power minus 3, that is 0.1 seconds. Nice. Yeah, I got the mental idea. I just did not know the maths. That's it. We did this one. So network layer, transport layer, data link layer. Data link layer, host to host communication. Yes, P is your answer. Yeah. So you just need to know what C does. That's it. That is the basic things of OSI stack, like open source interconnection, open source intercommunication. Yeah. Mhm. It is repeated, right? All right. Yep, there is an average of 8 marks for computer networks, and that is pretty good. We did one, two, three, four, five. So we did just 5 questions. 6, 7, 8, 9, 10, 11, 12, 13. Okay, there are 13 questions and two sets combined. That's that's some good stuff. All right. So regarding this one, so data link checking envelopes, you can say. Mm, network is checking best route. Transport is actual delivery. Communication. Mm-hmm. Yeah. Three-way handshake protocol. TCP header flags. So this should be easy as well. P1 P1 sends and P2 receives. P3. This is the three-way handshaking. So P3. This is synchronization. Syn. I see. Syn, right? So P3 is syn. Okay, wait. That's not how it works. I forgot how that one is. Yeah, syn 1, acknowledgement 0, syn 1, ACK 1. Alright. What is syn, by the way? Synchronize. Alright, P1. I wanna synchronize. P2. I I wanna synchronize too. I acknowledge it. I acknowledge your acknowledgement. Okay. Let's send that to ChatGPT. Nice. And we did this subnet masking already. We did that one, but I did not remember. Longest prefix match. Okay, kind of remember that, but mm-hmm. 5-bit message. I wanna do this one though. So 0.01 probability not flip is total minus at least one flip. Or maybe you can do this like 99% or 0.99 first bit not flipping. Yeah, so similarly 5 times. I need to do this one regarding subnetting. Once that is done, we will have one, two, my flag got instantly removed. I see. Okay, I want to reload that one. Right, so regarding subnetting, we need to do this now. There seems to be a problem with the network. The site got overloaded, it seems. No, thank you. Uh-huh. We did most of these questions. Mm-hmm. So if you look at it, it is going to be xy and obviously xy plus x bar plus y bar x. Okay, that is correct. And you can minimize this one though. If you don't know, like what do you say? If you don't know that, you can do this, you can always pull this one out. Xy is 0, so that will be 1, triple 0, x bar is 1100, and x times y bar. So 0 times 1 is 0, and 0, and 1 times 1 is 1. That is 0, alright. Any two are matching. So A, B, C, A plus B plus C. That is 1, that is 1, that is 1 and 0. XY bar is not matching. And X bar plus Y bar is like 1010. X bar plus Y bar plus X bar Y. So 1 plus, alright. Is 1 and that is 1 and that is 1 and X bar Y bar. That is 0, so that is matching. The 1 and 2, alright. X plus Y bar. X plus Y bar is 1, 0, so that's not matching. So both B and C are the answers. You can, if you know, like absorption law, AB plus A can be written as A plus B maybe. If A is false, AB is going to be false as well. If A is true, it is dependent on B. Yep, that is absorption law for you. Yeah, what I wanted to say is not to leave that question in the exam. We did not do this. We did not do this, man. Edge-weighted undirected graph is positive edge weights. So shortest path. So 3, 2. So weight of every edge got added with that. Okay.